In this video, we're going to be looking at glomerular filtration rate, a process that happens in the nephron of the kidney, but we're going to do it in a simple way so anyone can understand. So let's do it. What's up, bio nerds? Leslie Samuel here, and in the last video we looked at the nephron. We looked at it as the functional unit of the kidney and where the filtration, the reabsorption, the secretion, and elimination is basically happening. If you missed that, please go and check it out because there's great stuff there. A link to that and other resources in the description below. In this video, we're going to look at one part of that process, and that is what is happening in the glomerulus. Now, as a reminder, here we're looking at the nephron, and with the nephron, what we have is the afferent arteriole bringing blood into the nephron, into the glomerulus. You can see that structure right here, and from there, the blood leaves via the efferent arteriole. Now, what's happening in that glomerulus is a very important part of the process because that is where the filtration is taking place. If you look at the walls of the glomerulus, you'll see that it's permeable. It allows certain things to get through, but those openings aren't huge. So it's not going to get larger molecules like big proteins or larger structures like blood cells get out. If it's letting those things get out, then there's a problem and that needs to be evaluated. It's going to let certain waste products out, and that's exactly what we want. As you can imagine, if we affect the amount of pressure inside the glomerulus, you're going to affect the glomerular filtration rate. The rate of filtration in the glomerulus. Now, this diagram gives you kind of like a simplified version of what is actually taking place. So once again, we have the afferent arteriole leading into the glomerulus, and you can see those red arrows showing you filtration taking place so that the filtrate is then going via the Bowman's capsule and continuing on throughout the nephron. If any of that is confusing to you, please check out the video right before this one. And as you can imagine, there are certain situations in which we want that filtration rate to be higher, to get rid of more. And there are certain situations where we want to hold on to more of the stuff, so we want that glomerular filtration rate to go down. The question is, how do we influence this rate? Let's look at an even simpler illustration of this. So here we have an attempt at me illustrating the afferent arteriole coming up right here, going into this glomerulus. So I'm really simplifying the structure of the glomerulus right here, and then going down the efferent arteriole. Okay? So on this side, afferent, that side over there, we have the efferent, and in between here, we have a simple version of the glomerulus. And I want you to imagine that that glomerulus is permeable. It allows certain things to get out. The blood is coming in, it's going through the glomerulus, and because of the pressure that's in that glomerulus, we're going to have filtration taking place. So let's say this is the amount of filtration that's happening. How do we increase or decrease the amount of filtration? Have you ever had a hose that had water going through it and then you squeeze on one end? Well, depending on the end that you squeeze, if you squeeze the end that comes after the hole, what is going to happen to the pressure in that section? It's going to build up. And as that pressure builds up, it's going to force more out of, if there's a little opening, it's going to force more water out of that little opening. It's the same thing here. So imagine then, if on the end of the efferent arteriole over there, we make the diameter smaller. Somehow we adjust the diameter of that. What's that going to do to the pressure in the glomerulus? It is going to increase the pressure in the glomerulus. And as a result, we're going to have more filtration taking place. Now, on the other end, if we decrease the diameter of the afferent arteriole, there's going to be less stuff, less blood going into the glomerulus. And as a result of that, you're going to have less pressure, and then you're going to have less filtration. So the glomerular filtration rate is going to be significantly reduced if you reduce the diameter of the afferent arteriole. Now, because these are arterioles, we actually have some smooth muscle in the walls of these arterioles. And by constricting or relaxing the walls, the muscle in the walls of those arterioles, we can influence the diameter. And that is how we influence the glomerular filtration rate. So in the glomerulus, That is where the filtration is happening. And if we want to increase or decrease the glomerular filtration rate, we have to affect the diameter of those vessels that are either leading to or away from the glomerulus. Does that make sense? Of course it does. Like this video, subscribe to the channel, and I'll see you in the next video.